Alrighty, in this video, we are going to import Webpack into our modules example. So what I have here is I have the modules example along with my node modules. So I did run npm install before the video. Okay, so we're going to be using a Gulp file for this. So we're going to be running Webpack through Gulp. Again, you could certainly continue to use the Webpack command line directly. You could go into package.json and add in a Webpack script. Both of those are valid things to do. I would recommend adding the script into your package.json over using the command line tool directly, of course. But we're going to use Gulp. And just like with Browserify, I really like using a task runner such as Gulp for these sort of operations because it allows us to save code. There are multiple different scenarios in which we might want to invoke Webpack. We might want to do a development build, a production build, we might want to do a watch task or whatever. And by bringing it into Gulp and using the API directly, it allows us to share code and share bits of the task between all of those different environments. So I really still prefer to use a Gulp file. I am going to go ahead and I'm going to nuke our dev scripts and our dev styles and replace it with just our dev task. And our dev task is going to go ahead and instead of running those tasks parallelly, we're going to go ahead and just open up a nice little function there. And for our dev watch, I'm going to nuke this as well. And I'm actually going to replace this also with a straight up anonymous function because our dev watch task isn't going to rely on our dev task. The reason for that being dev is just going to compile all of our bundles, whereas dev watch is going to start the Webpack development server and perform a watch task, but the Webpack development server is going to perform its own compilation when it gets launched, so we don't need to worry about invoking the dev task. All right, let's go ahead and create our Webpack configuration. Well, actually, first of all, let's fix up our code a little bit. First of all, we will be jumping in here to our scripts, our application.js. We do want to pull in our jQuery and make sure that we pull in jQuery here. So import that from jQuery. If you're working on this from source or from the source code provided, you won't need to add that. That'll already be there. But in this case, you have to add that in there so that we can use jQuery on this page. And we're also going to load in our style sheets. So to do that, I am going to go ahead and pull down jQuery UI, Lodash, and jQuery itself. So I'm going to do npm install jQuery UI, and Lodash. Save dev. I do want to point out that you can configure Webpack to work with Bower if you want to. It's generally not recommended. It's generally recommended that you use npm as your package manager for your Webpack stuff. Now you can actually configure with Webpack, you can configure where it's going to resolve your external modules. And when I say external modules, I mean a module that does not have a / in front of it, meaning it's not a relative module. Now, you can certainly do that. There's configurations options for that. But in this case, we're just going to use straight up NPM modules, which Webpack understands without any additional configuration. Now that I have that, let's go ahead and load in our style sheet. So I'm going to say import, oops, didn't mean to do that. Import /styles site.less. And then I'm also going to import jQuery-UI, themes, UI darkness, jQuery-UI.css, and let's verify that that is the correct path. Wow, that's a lot of modules. So we do jQuery UI, themes, UI darkness, and jQuery-UI.css, and that is the CSS we want to load. So you see here, we are using the less loader and the style loader and the CSS loader. So with that in mind, I guess we can go ahead and import those as well before we write our configuration. We're going to need to npm install less loader, style loader, and CSS loader, and then save that. Make sure to save this to your package.json. And so that'll allow us to use this in our Webpack configuration. There's going to be an additional loader we're going to be needing here in a little bit, but we'll talk about that when it shows up. I just want to at least get Webpack bootstrapped and kind of configured enough to where we can move forward with this before we move on to talking about how to load in images and files. Anyway, so now that we have that, let's go ahead and jump into our public index.html, and I'm going to remove this link rel. In fact, I'm going to remove my scripts folder and styles folder, since we're not going to be compiling into those folders using the less compiler or the Babel compiler. We're not going to need them. Instead, I will go ahead and create a folder, and I'm going to call it assets. And then down here, I'm going to say script source equals / assets, and we'll do application.js. So our main application is just going to be application.js in the assets folder. So this is where we're going to be dumping all of our compilation artifacts. Okay, so that's all the changes we need to make to this example to work with Webpack. Now what we need to do is actually create the Webpack config and get it loaded into Gulp. So I'm going to create a new file. It's going to be called webpack.config.js. So I'm just going to use the default name here. Now, I am going to go ahead and say var path equals require path. I'm going to do something interesting here. Now, what I'm about to do is going to seem kind of odd, but I'll get the skeleton put together real fast, and then I will tell you exactly what's going on. So we have our config, we have our entry. I'm not going to fill out the config just yet, but I did make a function that returns our configuration. Then I am going to say module.exports equals config, but invoke it. Then I'm going to say module.exports.clone equals config. Now, config without the parentheses. Now, so what I'm doing is I'm making this compatible with the Webpack command line by exporting out the config. However, I'm providing a mechanism for if I load this config up in another node file, such as my gulp file.js, I'm exposing a function that will instantiate a new instance of my config whenever I request it. Now, that's important because some of our Gulp tasks are going to use this configuration as kind of a baseline. And then it'll add stuff to it or remove stuff from it to make it do what we want it to do. So, for example, we're going to have to do some different things if we're watching or if we're in production. So I could, up here, add in some flags, for example, to say, are you in development, production, whatever. But instead, I'm going to perform all the transformations of my config in my Gulp file. And I need a new copy of the config every time I mutate it, because when we require in our config module from Node, every time we require it in, we're going to get the same object back. And that's a problem because if we mutate that object, if in that same process, the same Node process, we reuse that config, then we've just kind of, well, we've changed or we've mutated that config from its default state. We will get unpredictable behavior. So again, I need to do this. I need to export the config directly so that Webpack understands it and can run it from the command line. I also want to go ahead and provide a way to clone or to get a new configuration object whenever I want, a copy of it basically, so that I can mutate it. So that's why I'm doing it. It looks a little weird, but it works very well. All right, for my entry, I'm going to say application is /source scripts application. So what I'm doing here is I'm defining my entry point in a different way. I'm opening up an object here, and I'm making this a named sort of chunk here. And the reason I'm doing that is to support the compilation of multiple files. In fact, I suppose I could build this example, just so you guys can see why I'm doing this, into what I'm doing right now. And inside source scripts, let's say I created another file called contact.js. Let's say we have 2 pages in our application. We have our main application, and then we have a contact page, which we want JavaScript on. And let's say I want to say import money from jQuery, and I wanted to say jQuery HTML text contact, or maybe jQuery body would be a better thing to do there. And so now I have this contact.js file that imports jQuery, right? So now if I wanted to have this be built out into a separate bundle, I could come back here to my Webpack config, and I can say contact is source scripts contact. So now I'll have 2 bundles generated. One for my application, one for contact. And later in this example, we're going to see how we can pull common files, for example, jQuery, out into a separate module like what we did with require. But now we have an issue. In my output, I am going to go ahead and say path is going to be equal to path.join dir name public, and then we're going to do assets. So that's where we're going to be dumping our stuff. But now I have a problem with file name. So I have to provide the file name, right? We need to know what bundle is going to be printed out. But I can't do application.js because then both my application and my contact bundles will be named the same thing. So instead what I'm going to do is I'm going to name it with a placeholder. So I'm going to surround it with square brackets and just say name. If you go into the Webpack documentation, you'll find a bunch of different placeholders you can use here. In this case, I'm using name, which is going to refer to the bundle name. So the first one will be application, and the second one will be contact. All right, let's go ahead and get this to work with Babel. So just like how we have Babelify for Browserify, we have a Babel loader for our Webpack. Now, I did forget to install that, so let's go ahead and hop over here and say npm install Babel loader. And once we have that, I'll just say save dev. Now, we already have Babel installed, and we have our presets installed, and we have our Babel RC file created. So all of that stuff is just going to work with the Babel loader. The Babel loader will go ahead and make sure that we have, or we'll use our Babel instance. We can ignore the unmet peer dependency right there because the version of Webpack that's currently being used does unfortunately not match that, that dependency, but that's fine for what we have here. Or actually, no, we don't have Webpack installed, do we? That's why it's there. Derp. So we should probably install Webpack too. Sorry about that, guys. I was like, unmet peer dependency, Webpack version 1. Did they sneakily release version 2 between this video and the last? No, I just needed to make sure I installed Webpack. So that's okay. So that's really cool about that peer dependency. It didn't pull down Webpack for me. It's forcing me to install Webpack in whichever version of that I want, which is a neat feature of how npm modules work. If you want to learn more about that, we talked about it earlier in this series. Now that we have our Babel loader installed, we can go ahead and open up our module object. Remember, this is where we define our loaders. And inside of loaders, we'll open up an array. Now, the first one I'm going to do is JS files. I'm going to say test, and then do a regular expression on .js. And then I'm going to say loader is Babel. Now, that's it, but that's not quite the end of the story. The problem with this is telling Webpack, yeah, you see a JS file, load it with Babel. But that's not necessarily what we want to do all of the time, because when we load up from Node modules, we don't want to run that through Babel. That's just going to add a bunch of additional processing that we don't need. Everything on npm has already been compiled if it was ever something else, so we just want to use straight up JS when we load things from npm. So what I'm going to do is I'm going to say exclude Node modules. Now, this is a regular expression, so I do use the slashes here instead of quotes. But what it's saying is exclude any file that matches this regular expression. In this case, exclude anything out of Node modules. Don't process them through Babel. That's just a waste of time. Let's do our less. So let's do test on .less. And the loader for this will simply be style bang CSS bang less. So we start from right to left. The first thing we do is tell it to go through the less loader. Then we tell that to go through the CSS loader, and then we tell that to go through the style loader. Remember, less compiles the less into CSS. CSS loads the CSS, and it imports the files that we may have imported through a file loader or something like that. And then the style loader is what's responsible for taking that CSS and adding it to our document at runtime when we load our script. All right, let's go ahead and also do a CSS one. So we'll do .css. And the CSS loader will simply be style bang CSS because we don't need to pre-process that. And that's it for now. We're not quite done, but we have enough going on here where we can kind of test it. So let's hop back over to our command line window, and I'm going to type in node modules.bin webpack and hit enter. Now we get a bunch of errors, and these I was actually expecting these errors for once. And we first of all see that we have two of our files being created, 2 bundles. We have our application and our contact. But then we get a bunch of errors saying that we don't know, it doesn't know how to deal with these GIF files and these PNG files and all that stuff. We don't have a loader in place that will load files from jQuery, or rather from any CSS. So let's go ahead and do that real fast. I mean, this is an easy thing to fix. It's just adding a loader. Generally speaking, if you run into an error with Webpack, you can usually fix it by adding a loader or configuring one. And the loader I want to use is the URL loader. Now this is really cool because this does everything that we had to do manually with Browserify when we talked about loading CSS with Browserify. This does everything automatically for you. So let's go ahead and npm install url-loader save dev. And the URL loader, like I said, it does everything that we had to do before. It'll copy the file, and then it'll change the CSS to reference the file. This will require a file loader as well. So we will say npm install file loader. save dev. I always forget that one too. Fortunately, the peer dependencies remind me. The file loader is going to be a loader that will take a file and dump it directly into our CSS file. So it'll actually take the images and base64 encode them and dump them straight into the CSS, which means that your browser doesn't have to do an extra request for an image. Now, generally speaking, you'll only want to use the file loader when the images are small, and you'll want to use the URL loader when they're big. Now, fortunately, there's a way that we can configurize what the limit is for when it's going to use the URL loader or the file loader. Anyway, let's go ahead and add another test here, or add another loader. And this one's simply going to be dot, followed by parentheses. We want PNG, JPG, JPEG, GIF, and WAF, and we can also do other things for fonts as well. I mean, we can go ahead and throw in, TTF, EOT, SVG, whatever you want to match here. Now the loader is simply going to be loader is going to equal URL loader. So the URL loader will fall back to the file loader if the limit isn't reached. So the limit's supplied by a query parameter. And I can say limit to 1024. So that means the URL loader, if the file size that we're trying to load is smaller than 1 kilobyte, then inline it directly into the file, hand it off to the file loader. If it's larger than a kilobyte, then go ahead and treat it as an external resource. Now if we run Webpack, whoops, I just installed that again. Now if we run Webpack against this current config, we see success. Not only do we see success, but we also see all of these GIFs and PNGs being emitted. Let's do an experiment real fast. So this guy is 1.74 kilobytes. So let's up the limit here to, what was that, let's up it to like 5 kilobytes. Or just to 5,000 bytes, whatever. And let's do that again. And now let's see what gets emitted. So give it a sec. Now you see fewer images are emitted. Fewer images are emitted because the rest are now being inlined directly into the bundle. So let's hop back over into our public assets and refresh. And in public assets, we now have all of our images. The images that were emitted before are still in here because it doesn't clean out that directory. So that's why there's so many images here. And we have our contact.js, which contains jQuery along with our contact.js file. We have our application.js, which includes everything from jQuery to jQuery UI to the rest of our application. And we'll also, if I search for base64, look at this. This list style image is now a data image base64. This actual image was brought in directly into the file by the file loader. And the rest of them are these .pngs. So like if I did a search for .png, notice how it's actually going and grabbing this file name and replacing this file name with the image itself. So that's really cool. So anyway, the previous base64 was a bad example. These are the ones that got actually embedded. The original base64 one was something that was already present in the CSS. But also, our less worked as well. So if I wanted to find that, I could simply search it off of my color accent and jump back into application.js. And we can see right here that our less module was indeed parsed and loaded in, and it'll be added into our page. So now, if I go ahead and open up a command line window, cd into public, do http-server, and refresh, check that out. So if I refresh again, look at what's getting loaded. Localhost, application.js, and that's it. Now, when I load one of these, I'm going to get an error because I didn't specify my base URL properly, or rather my public path. But so to fix that, I guess we have time for that. I would come back here into code. I would jump over to my config, and then in my output, I would specify where my public path is. And here, I'm just going to say assets. So that's the publicly located. That's the URL that's going to point to that output directory. So now, if I ran Webpack again, and then came back here, hit refresh, and loaded this up, and you need a slash. It's unfortunately not smart enough to notice that I didn't have a slash there. a forward slash. So it literally will just blindly append the public or prepend the public path on. Anyway, with Webpack ran, we now have images, and notice how the images are being loaded in. Anyway, that's it for this video, and we'll see you guys later.